Voyager to turn its camera back towards Earth, and it's what basically amounts to Earth's first ever selfie. And that picture was taken, and there was this pale blue dot.
Our profound understanding of the universe didn't emerge overnight. Voyager 1's unsettling new encounter with an unknown entity could reshape how we perceive space entirely. Without the groundbreaking journeys of these probes, many of humanity's greatest achievements and insights into the cosmos would remain beyond reach. Yet, after decades of venturing beyond Earth, one of these remarkable probes seems to be facing challenges. Join us as we explore the mysteries of space through the lens of these iconic explorers. The twin Voyagers, among the most significant space missions ever launched, have spent the past 45 years unraveling the secrets of the universe. Here's a look at their extraordinary journey. Over the past 45 years, fresh data has been continuously gathered. Think about this. When these missions began, there were no smartphones, no internet, and none of the modern conveniences we depend on today. Amazing, isn't it? Since NASA launched Voyager 1 in 1977, the spacecraft has spent decades exploring the cosmos, offering unparalleled opportunities to study the solar system. Here's an intriguing detail. The mission has far outlasted scientists' initial expectations. Despite extensive research on Earth, the conditions in space turned out to be remarkably different. Voyager's ability to navigate at planetary speeds and accomplish critical milestones with greater efficiency extended its mission from the planned 30 years to an extraordinary journey spanning nearly half a century. Despite launching 2 weeks apart and following different paths, Voyager 1 ultimately outpaced Voyager 2. Remarkably, it reached its destination in less than 12 years, a brief period by space exploration standards, and became the first spacecraft to approach the edge of the solar system. Voyager 1's journey was fraught with risks, including the possibility of failure or even becoming lost in the vastness of space. Nevertheless, these groundbreaking missions significantly expanded our knowledge of space travel. The twin Voyagers delivered invaluable data and awe-inspiring images that continue to captivate NASA engineers and scientists. Among their many achievements, they captured the first detailed images of Jupiter, showcasing the planet's iconic Great Red Spot. These missions have led to an array of incredible discoveries about stars and planets, including the identification of the largest natural satellite in the solar system, the detection of water on Europa, and the observation of active volcanoes on Io. They've enabled us to explore diverse locations across our solar system and uncover phenomena beyond our wildest imagination. Fascinating, isn't it? Nearly 13 years after its launch, Voyager 1 arrived at Saturn, its primary target. This achievement provided scientists with deeper insights into the planet, such as its brief 10-hour days and astonishing wind speeds. Compared to our familiar 24-hour days, 10 hours feels incredibly short. On Titan, Saturn's moon, we gained valuable knowledge about nitrogen-rich environments, while the discovery of 10 additional moons further broadened our understanding of this distant world. After gathering data from Saturn, the two spacecraft embarked on distinct missions. Voyager 1 set its course toward the heliosphere, while Voyager 2 pressed on to investigate the last 2 planets in our solar system. These missions not only answered many questions about the expanse of space, but also introduced new mysteries. For instance, Voyager 2 revealed unexpected details about Neptune, a planet once deemed less significant by scientists. They were both amazed and puzzled by how a planet so far from the Sun, receiving only minimal solar energy, could display such varied weather patterns and climates. Termination shock. Voyager 1 embarked on an extraordinary journey to the outermost edges of our solar system, venturing farther from Earth than any spacecraft before it. It reached the termination shock, a boundary where solar winds slowed drastically, from millions of miles per hour to just 250 miles per hour, a modest speed by space standards. In the vastness of space, nothing is truly small. Despite this achievement, Voyager 1 still needed to traverse the heliosphere to enter interstellar space. To put it into perspective, the heliosphere acts as a protective shield, guarding our planet and solar system from the intense energy and radiation of interstellar space. Over its remarkable 45-year journey, Voyager 1 has traveled an unparalleled distance of 12 billion miles. What's truly remarkable is that this accomplishment was achieved using relatively simple technology. Even though technology has advanced significantly since then, the probes didn't rely on microprocessors, as they weren't available just a decade earlier. The probe's impressive longevity can largely be credited to having little to no software. Scientists and engineers explained that hardwiring everything was essential to their improved performance. Although the onboard CPUs were low power compared to modern standards, they were crucial in enabling the probes to operate for such a long time. The instruments on the probes gathered and recorded data using an 8-track tape recorder, a device that consumed about as much power as a refrigerator light bulb to send information back to Earth. Isn't that amazing? It's astounding to think about what we achieved with such outdated technology. Could we have done all of that without modern conveniences like touch screens and advanced systems? This rocky beginning raises some significant questions. Is Voyager 1 experiencing issues? After 45 years in space, have we finally made contact with aliens? Could there be a simpler explanation, or is space travel riskier than we anticipated? After decades of exploration, how well is our reliable Voyager 1 holding up? How is Voyager 1 doing? Voyager 1, now over 1 billion miles from Earth, continues to function after decades in space, a testament to its remarkable engineering. However, after 35 years traversing the vastness of space, the spacecraft is showing signs of wear. Scientists have found they can no longer pinpoint its exact location, despite it appearing operational. While Voyager 1 hasn't triggered alarms or entered safe mode, its precise position remains unknown. NASA experts are intrigued, but not entirely surprised. It's expected for a probe of this age to encounter challenges. The big question is, what's happening to Voyager 1 as it ventures deeper into uncharted interstellar space? Is it merely the effects of aging, or could there be a deeper mystery at play? Some scientists suspect the spacecraft may be experiencing electronic aphasia, a condition that disrupts its ability to communicate clearly, complicating the interpretation of its transmitted data. NASA has indicated that some of the data Voyager 1 is sending back appears nonsensical and unrelated to the Attitude Articulation and Control Systems, ACS, the system that keeps its high-gain antenna pointed at Earth. Instead of normal status updates, the ACS has been transmitting scrambled, incoherent information. In the last 3 years, NASA has successfully extended the spacecraft's energy supply by shutting down non-critical systems, allowing the mission to continue until 2030. However, some challenges may still arise. Interestingly, even though it's been receiving incorrect signals, the radio communication remains as strong and steady as ever, providing reassurance. This consistency indicates that Voyager's antenna is still properly aligned with Earth, confirming the probe's correct orientation, despite the inaccurate location data. The problem didn't activate the fault protection system, which is meant to protect the spacecraft in case of failure. After a thorough investigation, NASA experts discovered that the ACS had been transmitting telemetry data through an onboard computer that had malfunctioned years ago. They've since fixed the computer to prevent further issues, ensuring Voyager 1 continues to function smoothly. The golden record on both Voyager spacecraft acts as Earth's message to the universe. It's translated into 55 languages and includes music, as well as images of key people and landmarks from our world. Humanity's curiosity about reaching out to extraterrestrial life seems endless. Jamie Rankin, an astronomer and member of the Voyager project, shared his thoughts on the mission's future. He expressed pride in the project's extraordinary, unanticipated success, which relied on the efforts of teams across generations. No one could have predicted that such outdated technology would last this long in space, but it has. While the ongoing efforts behind the Voyager missions often go unnoticed, these two probes continue to play a crucial role in expanding our understanding of space, still at the forefront of exploration, even as their visibility has waned.